chemical reactions need a reason to occur. That reason could be formation of a gas, or in the case of a neutralization reaction, it could mean the formation of water, or in the reaction we're about to take a look at, it could involve the formation of a precipitate. So when one product forms in a reaction, in this particular type of reaction, which is called a metathesis or exchange reaction, where you have two compounds that basically swap partners, when one of those products that forms is not soluble, we refer to that substance as a precipitate. So in this particular reaction, we have two colorless solutions. One is potassium iodide, and that's aqueous in solution, and the other is lead nitrate. Also aqueous in solution. And so when those two combine, we end up with the two outer ions forming potassium nitrate, which is a soluble salt, so that will be aqueous. And the compound that's formed between the lead and the iodide is going to be lead to iodide. Now, this particular substance is an insoluble compound, and that's what you see right here, that yellow granularly looking stuff. So we're going to give that the designation of a solid. And if we go ahead and balance that equation, we're going to need a 2 here and a 2 here. Now, this is considered to be a molecular equation because it shows the chemical formula of the reactants and the products. So our two reactants that we're looking at were potassium iodide, and it says here all potassium salts are soluble, and lead nitrate, and it says here all nitrates are soluble. And so I know I have two soluble compounds in aqueous solution. Now when you put those two together, my products, as we wrote in the reaction before, in the equation before, we're going to be potassium nitrate, again, potassium salts and nitrates soluble, and the other product was lead to iodide. Now, that's not specifically listed on this table, but I will tell you that it is an insoluble compound, so it does form a precipitate. It's really good to be able to recognize when a precipitate forms. So taking a look at this table and familiarizing yourself with what kinds of salts are soluble and insoluble will be really helpful for you. So since both potassium iodide and lead to nitrate are soluble salts, when they're in solution, they're going to be dissociated as ions in the solution. So what I would actually have in one beaker would be potassium iodide existing as ions in solution. I would have 2 potassium ions and 2 iodide ions. And in the other beaker in solution, I would have lead 2 nitrate dissociated into lead 2 ions and nitrate ions. Now when I put the two together, the lead is going to react with the iodide and it's going to form lead 2 iodide, which is our solid precipitate. And our other ions, our potassium ions and the nitrate ions, presumably would come together to form potassium nitrate, but again, another soluble salt. So potassium nitrate in solution is going to exist as dissociated ions. So I'm going to again have 2 potassium ions floating around in there and 2 nitrate ions as well. So the actual reaction that occurred happened between the iodide and the lead, forming the lead 2 iodide, the solid precipitate. The potassium ions existed as ions on the reactant side, still exists as ions on the product side. So since they are ions that did not take part in the reaction, basically they're sitting around doing nothing, we refer to them as spectator ions. So I just rewrote that a little bit to make it neater, and in this form, this would be considered a complete ionic equation. But it's pretty cumbersome. So what we can do is cross out all of the spectator ions, and that would be just looking at the equation and seeing which ions are on both sides of the equation as reactants and products in the same form. So I have potassium ions on this side of the equation and potassium ions on this side of the equation. Neither of them changed forms from reactant to product, so they didn't take place in the reaction. They're spectator ions. Same thing with the nitrates. I have 2 nitrates here on the reactant side. I have 2 nitrates on the product side. Again, spectators did not actually take part in the reaction. And what you're left with then is going to be 2 iodine plus a lead 2 in solution, forming lead 2 iodide. And that is the net ionic equation. Ta-da!